In the silent, unforgiving vacuum of space, humanity's outposts like the Mir space station represent a delicate balance. They are cocoons of life, meticulously engineered to sustain human existence against the immense hostility of the void. Every component, every system, is designed to keep the breathable atmosphere in and the lethal vacuum out. But what happens when that fragile shell is breached? When a routine operation goes catastrophically wrong, and the very integrity of an orbital home is suddenly, violently compromised? The year was 1997. The Mir space station, a marvel of Soviet engineering, had already served for over a decade, pushing the boundaries of long-duration spaceflight. It was a scientific laboratory, a proving ground for international cooperation, and a testament to human perseverance. Its modules, interconnected and robust, had withstood countless challenges. But June 25 of that year would test Mir and its crew in an unprecedented way, revealing just how vulnerable even the most advanced space habitats can be. The event began as a seemingly routine resupply mission. A Progress M34 uncrewed cargo spacecraft, laden with vital supplies, was approaching Mir. These automated vehicles were essential for keeping the station stocked with food, water, and equipment. Usually, the docking procedure was handled by automated systems, a precise ballet choreographed by computers. But this particular rendezvous was different. It was part of a test, intended to refine manual control capabilities for future missions and emergencies. The mission objectives for Progress M34 included testing a new manual remote control system, known as Toru, which allowed the Mir crew to guide the Progress spacecraft using a joystick and camera feeds. This was a critical exercise to understand how cosmonauts could manually intervene or dock if automated systems failed. The test involved undocking the Progress and then redocking it manually, with the crew having full control over its trajectory and speed. It was a high-stakes simulation in a real-world environment. From inside Mir's control module, the crew meticulously guided the Progress. They were highly trained professionals, accustomed to operating complex systems under immense pressure. But the Toru system, while offering greater flexibility, also introduced the human element into a process usually handled with machine precision. The margin for error in orbital mechanics is virtually non-existent. Even minor miscalculations can have exponential consequences in the vastness of space. Every input, every adjustment, was critical. During the manual redocking procedure, a critical mechanical failure of the manual docking system occurred. The Progress spacecraft, instead of approaching gently and precisely, veered off course. It began moving too fast, and its trajectory shifted unpredictably. Despite the crew's desperate attempts to correct its path, the vehicle became increasingly difficult to control. What was meant to be a controlled test quickly escalated into an uncontrollable, high-speed approach that spelled impending disaster for Mir. The inevitable happened. The Progress M34, moving at an unexpected speed, slammed into the Mir space station. The impact was not a glancing blow, but a direct hit on one of Mir's most vital modules, Spektr. The crew inside Mir felt a violent jolt, accompanied by a sickening crunch that resonated through the station's structure. In the serene environment of orbit, such a sudden, forceful impact was utterly shocking, a sound and sensation that no astronaut ever wants to experience. Immediately following the collision, chaos erupted. Alarms blared throughout the station, signaling a catastrophic breach. The most terrifying sound, however, was the sudden, loud hiss of air escaping into the vacuum, the unmistakable sound of depressurization. Within seconds, the crew realized the gravity of the situation. A module had been punctured, and their precious, life-sustaining atmosphere was rapidly bleeding away. This was not a drill, it was an existential threat demanding immediate, decisive action. The impacted module was Spektr, one of Mir's scientific modules, crucial for Earth observation and materials processing experiments. It was also equipped with large solar panels that generated a significant portion of Mir's power. The Progress spacecraft had torn a gaping hole in its hull, effectively rendering it useless and transforming it into a gaping wound on the station's side. Visual confirmation from the crew revealed not just a puncture, but a severe, structural compromise. With the breach in Spektr, the station experienced a rapid loss of pressure. The air, painstakingly accumulated and maintained, was now rushing out into the vacuum of space. The crew watched in horror as pressure gauges plummeted. This sudden depressurization was not just a loss of air, it meant the loss of breathable oxygen, the very essence of life support. The environment inside Mir quickly became hostile, demanding swift action to prevent further critical pressure and oxygen loss. The immediate danger was clear: if the depressurization continued unchecked, the entire station would quickly become uninhabitable. The remaining oxygen supply, carefully regulated to sustain the crew, was now threatened. Every passing second meant less breathable air, increasing the risk of hypoxia and eventual suffocation for the astronauts. The clock was ticking, not just for the station, but for the lives of the crew on board. They had to act, and they had to act fast, to preserve what little oxygen remained. With their lives hanging in the balance, the crew made a desperate but critical decision: they had to isolate the damaged Spektr module from the rest of the station. This meant sealing off the connecting hatches to prevent further depressurization of Mir's habitable sections. It was a race against time, as the structural damage was compromising the sealing mechanisms of the hatches themselves. This radical move was the only way to save the core of the station and, critically, the lives of its inhabitants. The challenge was immense. While hatches were designed to seal, the structural integrity around the Spektr's access points was compromised by the collision. Conventional sealing methods were failing. The crew had no prepackaged, purpose-built emergency repair kits for such a catastrophic breach. They were forced to improvise, relying solely on their training, ingenuity, and whatever materials they could find within the station. This was the moment where human resourcefulness would be tested to its absolute limit. This is where human ingenuity truly shone. The crew began to fashion makeshift seals using whatever materials were available. Sheets, blankets, clothes, duct tape, even food packaging, anything that could be stuffed into gaps or wrapped around compromised hatches. These crude, improvised barriers were designed to stem the flow of air, slowing the depressurization enough to allow a full, secure seal of the hatches. It was a desperate, manual effort, transforming everyday items into life-saving tools. Working against the clock and the relentless pull of the vacuum, the astronauts struggled with immense physical effort. They pushed, pulled, and stuffed materials into place, their movements complicated by weightlessness and the urgency of the situation. Every action was fraught with danger. A slight error, a moment of weakness, could mean further compromise or a complete failure to seal. The silence of space outside contrasted sharply with the frantic, desperate struggle unfolding within the station's confines. Through sheer determination and remarkable ingenuity, the crew succeeded. After a tense period, the makeshift seals held, allowing the damaged Spektr module to be fully isolated. The immediate crisis of rapid depressurization was averted. The rest of Mir, though shaken, was saved. This incredible feat preserved the station's remaining oxygen and pressure, buying the crew critical time and ultimately securing their survival. It was a testament to their training and their ability to think on their feet in the most extreme circumstances. While the Mir space station was saved from total destruction, the collision left an indelible scar. The Spektr module, a key scientific segment, was permanently lost for functional use. Its solar panels were no longer optimally aligned, and its interior was exposed to the vacuum. Mir continued its operations, but with reduced power and capabilities, serving as a constant, stark reminder of the near catastrophe. The incident highlighted the inherent fragility of pressurized space habitats and the fine line between success and disaster. The Mir collision starkly underscored the inherent dangers of orbital rendezvous. Even with advanced technology and highly trained crews, the immense speeds and unforgiving environment of space make any close approach incredibly perilous. A slight error in calculation, a minor mechanical glitch, or a moment of human misjudgment can swiftly escalate into an existential threat. It's a precise, high-stakes ballet where a single misstep can have devastating, irrecoverable consequences. This incident vividly illustrated the fragility of pressurized space habitats. These orbital outposts are complex ecosystems designed to protect life in an environment utterly hostile to it. A breach, however small, can quickly turn into a race against time as the station bleeds its vital atmosphere. The mere collision served as a grim reminder that our homes in space are always on a thin line, perpetually vulnerable to the forces of the cosmos and the unpredictable nature of human and mechanical error. Perhaps the most profound lesson from the mere collision is the critical role of human ingenuity when automated safety systems fail. When technology faltered, it was the quick thinking, adaptability, and resourcefulness of the crew that ultimately saved the station and their lives. Their ability to improvise makeshift seals from everyday items under extreme pressure highlights the invaluable human element in space exploration, the capacity to overcome unforeseen challenges through intelligence and determination. The mere collision became a powerful case study for future space station design, emergency protocols, and astronaut training. It emphasized the need for more robust damage control procedures, redundant safety systems, and comprehensive training in improvised repairs. The lessons learned from that harrowing day directly influenced the design and operational philosophies of the International Space Station, making it more resilient and better equipped to handle similar catastrophic events. The sacrifice of Spektr ensured safer journeys for generations to come. The mere collision of 1997 remains one of the most significant incidents in the history of human spaceflight, a stark reminder of the ever-present risks. Yet, it is also a powerful testament to the resilience of the human spirit. The crew's extraordinary response, their courage, and their ingenuity transformed a near-fatal disaster into a story of survival and invaluable learning. It etched into the annals of space exploration the enduring truth: even when automated systems fail, human determination can prevail against the ultimate adversary, the vacuum of space.